Right, so when you ask to solve equations where there's just logarithms every term, okay, slightly different approach, all right? But again, you need to be thinking about getting single logarithms, okay, getting them as single logarithms. But because we've got logarithms on both sides here, let's just try and group these two together, okay, and then write this as a single logarithm, and we can see then what happens. So here I can write that as a single logarithm easily because it's taken away, so it's the division law, okay. So that will be 5x plus 1 divided by x, yeah, because we've taken away using our second law. On the right hand side then, okay, well, because I've got the term in front here, I can take it up, can't I, as a power, okay, using the power law, the third law, so that'll be log to the base a of 2 cubed, yeah. Now, something interesting happens now. When I've got a single logarithm on both sides, I can actually sort of cancel out the logarithms, okay? I'm allowed to do that because if the log of this equals to the log of that, then this has got to equal that. You can sort of like cancel out the logs because the fact you've got logs on both sides, okay? Just like when you cancel down an equation, you know, if you've got like a factor of 2 on both sides, you can divide by 2, okay, and cancel it out, and it's the same thing here. So the logs cancel, and I'm left with 5x plus 1 over x equals to then this, which of course, well, 2 cubed is 8, isn't it? So I can write that there. So then, simple equation, take the x up. So I get 8x, and then get the x's onto one side. So if I take that 5x over there, I'll have 1 equals 8x minus 5x. So 1 equals 3x. So that means then x has got to equal a third, isn't it? Okay, so I've solved it, okay? Solved my equation. So different to the previous video, because here I've got, you know, just logarithms involved. So, you know, if you group them, you get logarithms on both sides. It enables you then to sort of cancel out the logarithms. It's just a slightly different way of solving the equation, that's all, okay? So you could see I could do the same thing here then with this one, okay? And let's put these two together, okay? Multiplication law in this case now, because I've got an addition here, so I can multiply these terms. On the right hand side then, of course, you know, the term in front there, that number in front, you've got to take it up as a power using the third law, the power law. And again then, you can see I've got single logarithms on both sides, so they can cancel out. Okay, right, so they cancel out. I'm then left with to work out, to solve this then essentially, okay? So I'm going to need to expand this here, okay? Perhaps, you know, we'll, well, it doesn't matter really the order, maybe I'll take a bit of time on this now. So 16x take away 1, x plus 2, and on this side then 4x plus 3, 4x plus 3, because it's squared. So if I just expand this now, just a minus there, of course, a bit of a slip there for me, but if I expand that, I get 16x squared plus 32x minus x minus 2, and on this side then I get 16x squared plus 12x plus 12x plus 9. Okay, so you'll notice the 16x squared on both sides, so they'll cancel. I've got 31x minus 2 here, and I've got 24x plus 9 there. Get the x's to one side, so I'll have 31x minus 24x, and get the numbers on the other side, so I've got 9 then plus 2. So I've got 7x here, and I've got 11 there. That means then x has got to equal to 11 sevenths, okay? And we just leave it there like that as a fraction.